Welcome students, we are given this question: x negative 1 times y negative 1 times z negative 1 is equal to x y z negative 1, and then x negative 2 times y negative 2 times z negative 2 is equal to x y z negative 2. We are asked to solve this equation. So we got equation 1 and equation 2, and the domain given is R, real numbers. Now there are two things you have to observe. One is that we got three variables, x, y and z. Number two, we got only two equations. Number three, the domain is set of real numbers. So with all these three observations, let us start by considering equation 1 and start our journey of solving this. So I'm going to consider 1. So from 1 I can write, I would like to multiply two things at a time. So I would just multiply x negative 1 with y negative 1 first, and then I would multiply z negative 1 and then equate it to x y z negative 1. So that's what I'm going to do. So x into y and then x into negative 1, that's going to be x, followed by negative 1 into y, that's negative y, and then negative 1 into negative 1, that's going to be positive 1. Now I would multiply with z negative 1. Of course on the right side it's x y z negative 1. So this is going to be xy into z, so xy into z, and then xy into negative 1, so it's going to be negative xy, and then negative x into z, so x into z, and negative x into 1, that's going to be positive x, then negative y into z is going to be y into z, and negative y into negative 1, that's positive y, then 1 into z, and then 1 into negative 1, that's going to give me negative 1. On the right side it's x y z negative 1. Now clearly xyz and xyz can be cancelled. I have xy, I'm going to take a negative sign out, so this is going to give me xy, and then I will follow it up with yz, positive y into z, and then z into x or x into z. So I prefer to write it as z into x. So that's one quantity. I got a x or a y, a z. So let me write that down. X added with y added with z. I got a negative 1 and a negative 1. So these two components can be cancelled, giving me equal to 0, right? So if I were to rewrite this, I would have x positive y positive z is equal to, I move this negative on the other side, it will become positive, so it's going to be xy positive yz positive zx. So let me take that to be equation number 3. Now I'm going to consider equation 2. So let me write that down. Consider equation 2. So I get x negative 2 multiplied with y negative 2 multiplied with z negative 2 is equal to x y z negative 2. This is what is given. As usual, I will multiply two components at a time. So x into y, I get xy, then x into negative 2, that's going to be negative 2 times x, and now 2 into y, that's y into 2, or whatever that is comfortable to you, that's going to be negative 2 times y, and negative 2 into negative 2, that's going to be positive 4. Now this has to be multiplied with z negative 2. Of course on the right side you get x y z negative 2. So let's do the multiplication. Xy into z, that's the first component, so let me write that down, xy into z, and then xy into negative 2, that's going to be negative 2 times xy, and then negative 2x into z, that's going to be negative 2 times xz, and then negative 2x into negative 2, that's going to be positive 4x. Then negative 2y into z, that's going to be negative 2 times yz, and negative 2y into negative 2, that's going to be positive 4 times y, and then 4 into z, and then 4 into minus 2, that's going to be negative 8. On the right side I get a xyz negative 2. Now xyz can be cancelled. I get a negative 2xy, and then negative 2yz and negative 2zx. So I can take a negative sign out and then rewrite it as 2 negative 2 of xy positive yz positive zx. Then I get a 4x, a 4y, and a 4z. So positive 4 times of x positive y positive z. And then I get a negative 8. I can push the negative 8 to the other side. That's going to be positive 8 negative 2, which would give me 6 here. Now I get xy positive yz positive zx. Now if you were to go up and see in 3, I get xy positive yz positive zx is equal to x positive y positive z. So what I wish to do is substituting. You can just say put 3 in 4. So if I were to take this as 4, so put 3 in above. You can mention it as above or 4, whatever you are comfortable with. So this is going to be negative 2 of xy positive yz positive zx is going to be x positive y positive z, and then I get a positive 4 times of x positive y positive z. This is going to be equal to 6. Now adding up these two would give us 2 times of x positive y positive z is equal to 6. From here I can rewrite x positive y positive z is equal to 3. So this can be taken to be as number 5. Now this is a very important equation, x positive y positive z is equal to 3. Now if I were to use this in above in 3, so therefore I can rewrite 3 as x y positive y z positive zx is equal to 3. Okay, so this is my equation 6. So this is a very important observation. Now what I wish to do is from 5 I can rewrite 5. So from 5 I know we need to do some alterations for getting the solution. So I wish to rewrite 5 as z is equal to 3. I'm taking x and y out, so that's going to be negative of x positive y. So this is what I get. Okay, so this is going to be an important substitute. So I will try to divide this space into 2 because I would like to show you another method, because this particular question can be solved in different ways. So I have planned to show you 3 different methods. So in this space I would continue my solution. So what I wish to do is I would be taking the value of z and I would be substituting in 6. So from 5 we get this, and substituting, okay, in 6 we get, so what do we get? I'm not going to touch x and y, they remain as it is, and then in place of z I would be substituting this quantity. So this is going to be 3 negative of x positive y followed by positive of 3 negative 3 negative of x positive y in place of z, right? This has to be multiplied by x, and on the right I've got a 3. So I would have to expand this, which I'm going to do now. So this is going to be x into y positive 3 times y, and then y times x, xy, and then negative y squared, followed by x times 3, 3x, and then negative x times x, that's going to be negative x squared. So negative y times x, that's going to be negative xy, is equal to, you got a 3 here. Now I wish to convert this as a quadratic equation in y. So I'm going to take this term y squared and I'm going to collect all the y terms. So I get a y term here, and I get a y term here, and is there any other y terms? So I have to look for all the y terms that I can look for. So there is a negative xy, a negative xy, and a positive xy. So what I can do is I can cancel this xy with this xy, and I can club 3y with negative x times y. So let me take that y out. If I were to take that y out, I would have a 3 followed by a negative x. So that is fine. So after which I get a 3x term, a x squared term, and a 3 term. So I will bring the 3 down here, and then I will write this as, I get a negative x squared and a positive 3x and a negative 3 is equal to 0. So this is what I've got. Now before I could proceed, let me just place in one more step. So this is negative y squared positive y times of 3 negative x, and this is negative of x squared. I'm taking the negative sign out, so negative 3x positive 3 is equal to 0. Now I want to remove this negative sign out, so I'm multiplying by negative 1 both sides. So multiply by negative 1 both sides. So if you were to do that, this would become y squared, this would become negative of y of 3 negative x, and this would become positive of x squared negative 3x positive 3 is equal to 0. Okay, that's what you got. Now using the quadratic formula, this is going to be minus of, the quadratic formula is negative b, right? So if you were to use this formula, this is going to become positive. So it's going to be 3 negative x. So of course on the left side you get y. We are solving for y. So 3 negative x plus or minus square root of 3 negative x raised to the power of 2 negative 4 times of this entire quantity x squared negative 3x and positive 3. Okay, 4ac divided by 2 times a. 2 times a is 1. Now I would like to expand this quantity, so that's going to be 9 negative 6x positive x squared, this is 4x squared positive 12x negative 12. Now of course this is in square root, and you get 3 negative x plus or minus divided by the denominator, which is 2 here. Now x squared negative 4x squared, that's going to be negative 3x squared, and then you get a negative 6x positive 12x, that's going to be positive 6x, and then you get a 9 negative 12, that's going to be negative 3, right? This is what you got, and everything is in square root. Now let me just have 3 negative x here divided by 2. Now just make an observation of this this is nothing but, if I were to take 3 out, let me just take 3 out. If I were to take 3 out of here, this is equal to this. I'm going to take negative 3 out. If I were to take negative 3 out, this is going to be x squared negative 2x positive 1, right? Now of course you got 3 negative x here plus or minus divided by 2. Now x squared negative 2x positive 1, what is this exactly? This is nothing but x negative 1 raised to the power of 2. This is whole squared, and then you got a negative 3, and then you have a square root, and then you get 3 negative x plus or minus divided by 2. Okay, so this is equal to y. Now x negative 1 is going to be positive, because x negative 1, I should say x negative 1 raised to the power of 2 is going to be positive, right? No matter what, for all values of x, present in the domain R, right? Because you're squaring it, so this is going to be positive. But when you multiply this positive quantity by negative 3, this is going to become negative. But the problem is we have a square root, and that would mean this quantity which we see inside the square root would require a complex initiation, or I would say, if I were to rewrite this as some quantity, then I would have to take the support of complex numbers, which would contradict the problem, because the problem clearly says that this domain that we are focusing on should be R. So all the elements that we have, x, y, z, they are all present in the domain R. So that is a big issue. So if we let this quantity within the square root go ahead, then we are contradicting the problem's domain. We can't do that. So what is the only alternative we got? This has to become 0. So when will this become 0? The only time that this can become 0 is when x is equal to 1. So when x equal to 1, this becomes 0. So that's exactly what I'm going to do. So let me just I'm not going to touch the space, I need the space, so let me just do that here. So y is equal to 3 negative x plus or minus square root of negative 3 of x negative 1 raised to the power of 2 divided by 2. So this has to vanish, and it will vanish when x is equal to 1. So this becomes 0. So now we are left with y is equal to 3 negative x divided by 2. Already x is equal to 1. So this would mean 3 negative 1 divided by 2, which is nothing but 2 over 2, which means my y is equal to 1. So we got y, we get x, and there is a relationship that connects x, y, z with 3. So I substitute x, I substitute y, so it's 2 plus z is equal to 3. So I can say from 5, 2 plus z is equal to 3. So this means z is equal to 1. So I've got the value of x, I've got the value of y, I got the value of z, and that solves the solution to this question. So this is the first way of getting the solution, but this is not the complete way. In fact, of course, we are arguing that x will be equal to 1, y will be equal to 1, z will be equal to 1 because of the domain. But mathematically speaking, we need to provide some other reasoning, more concrete, to ascertain that x equal to 1, y is equal to 1, z is equal to 1 are the only solutions. So that is going to be done by method 3. Okay, now let us go on with our method 2. Now I'm going to use the space here. Now if you could remember, we had come up unto this particular point. Now from here I would like to take a deviation, and that deviation is going to be adopted in the following fashion. So what I'm going to do, I'm going to square 5, and then I'm going to multiply 6 by 3, and then I'm going to subtract these two. This is what I'm going to do. So if I were to square phi, I would get x positive y positive z raised to the power of 2 is equal to 9. So this is my new system. Let me name it as phi dash, and I'm going to multiply equation 6 by 3. So this is going to be 3 times of xy positive yz positive zx is equal to 9. This is going to be my 6 prime. So what I want to do is, now I'm going to subtract 5 prime minus 6 prime. 5 minus 6 prime. In other words, 5 prime minus 6 prime. That's the best word to say. So if I were to do that, what would I get? I would get x positive y positive z raised to the power of 2 minus of 3 times this quantity, right? 3 times of xy positive yz positive zx, and of course this is going to be equal to 0. The 9 and the 9, they get cancelled. Now if I were to expand this, x positive y positive z the whole squared, I would get x squared positive y squared positive z squared positive 2 times xy positive 2 times yz positive 2 times zx, followed by negative 3 times of xy positive yz positive zx. Of course this is equal to 0. Now we can't do anything about these terms, all these 3 terms, but we can always add 2xy with negative 3xy, with negative 3x, and 2yz with negative 3yz, and 2zx with negative 3zx. So what happens when we do that? So let's do that. So this is going to be x squared positive y squared positive z squared. Now when I add it, I would get negative xy, negative yz, and negative zx is equal to 0. Now all this term, this entire term, can be rewritten as x minus y raised to the power of 2 positive y minus z raised to the power of 2 positive z minus x raised to the power of 2 is equal to 0, right? Is equal to 0. Okay, now when you expand this, you will get actually x squared positive y squared. When you expand this, you get y squared positive z squared. So that means you have a presence of 2 y squared terms, 2 x squared terms, and 2 z squared terms. And similarly, you will have 2xy, 2yz, 2zx. But we just have 1zx, 1yz, 1xy. Of course, the signs are there. So the best thing to do is to divide this entire thing by 2. So that would neutralize whatever we get. Now this is rewritten as x negative y. So let me write this down. So this means I can rewrite this as x negative y the whole squared positive y negative z the whole squared positive z negative x the whole squared is equal to 0. Now here comes the argument. Now you see that x negative y is a square, y negative z is a square, z negative x is a square. That, in other words, I'm just taking a square of these 3 terms. Now we know that x comma y comma z, they're all present in the domain, real numbers. Now when can the squares, some of these squares be equal to 0? The only possibility for these squares to be equal to 0 when this is equal to 0, this is equal to 0, this is equal to 0. That is the only time when some of these squares will be equal to 0. So that would mean this can only be possible when x negative y is equal to 0, y negative z is equal to 0, and z negative x is equal to 0. So what does this mean? X negative y is equal to 0. This would mean x is equal to y, this would mean y is equal to z, this would mean z is equal to x, right? So you got x is equal to y, y is equal to z, and z is equal to x. So what is the meaning of this? So this means, this would mean, I'm using the space, x is equal to y is equal to z. So that is the meaning of this. So indirectly, what are we trying to say? We are trying to say that the only possibility for this is going to be x should be equal to 1, y should be equal to 1, and z should be equal to 1. And when this happens, this would mean x should be equal to 1, y should be equal to 1, and z should be equal to 1 for this equation to be true. So this is method 2. Now comes the method 3. So I hope you understood the method 2. So clearly we have come to this conclusion that x is equal to y is equal to z, and the only time that equation 5 can hold good when x is equal to 1 and y is equal to 1 and z is equal to 1. So that is the argument. Okay, now method number 3. Now this is to ascertain that x is equal to 1, y is equal to 1, z is equal to 1 is the only solution possible for this particular system. Now just consider system 6. Now if I were to take y to be equal to x and x to be equal to z and z to be equal to y, that's fair enough. What happens? What do you see here? If I were to make this transformation, y being equal to x, x being equal to z, and z being equal to y, what happens to system 6? Now this is acceptable. Why is it acceptable? Because clearly we know x should be equal to y, y should be equal to z. So this is what we have achieved. Now what happens when I do that? Clearly I see that x squared positive y squared positive z squared is equal to 3. Now what is this? Can you tell me what is this? Okay, let me use the space. So what is this exactly? X squared positive y squared positive z squared is equal to 3. This is nothing but the equation of a sphere. But we have also got x positive y positive z is equal to 3. What is this? This is the equation of a plane. Now we got two systems. This is convex, this is a plane, and if a plane has to meet a sphere, it is possible at just one point. At just one point. So the plane will meet the sphere at just one particular point. So we are talking about something like this, right? And that point would be a tangent, and hence I can clearly say that x is equal to 1, y is equal to 1, z is equal to 1 is the only solution for this question. Thank you, students.